Ladies and gentlemen, I thank Sanjeev and the organizers for this event, for inviting us onto this platform to participate in a very crucial dialogue around building an integrated ecosystem for domestic battery manufacturing value chain, from mineral processing to gigafactories to system engineering that efficiently integrates new and sustainable energy resources into energy and mobility applications. I know this is an EV conference, so our discussions will be focused around largely EV application. But when it comes to batteries, supply chain, manufacturing, ecosystem, you can't separate EV and energy storage markets. So there will be some overlap in the conversation as I see. I am Vijayanand. I worked for Amaraja Group for a long period of 33 years plus and very recently retired. And whatever little that I have learned during my career, that keeps me connected to the industry and my network. So happy to be here. India's electric mobility and energy transition journey has reached, as we all know, a very pivotal moment. There have been times in the past where a lot of discussions were happening in conference rooms, but I think the action has started to happen on the ground now. And the exhibition is a good example of what it is. And many such, agenda points are being executed now, no longer just being debated and deliberated. Over the last few years, we have witnessed increasing momentum in investments in gigafactories, battery manufacturing, energy storage infrastructure. But the true measure of success will not be the number of gigawatt hours that we install or we use. It will be our ability to build a deeply integrated, resilient, and circular battery ecosystem in the country for the world. And this has been emphasized. I think if you try to focus on what India needs, we will have a lot of reasons to complain about scale not being there, competency not being there. But if you look at world as your market, I think certainly the opportunity opens up a lot. Just to give you a sense of what that opportunity, even just to look at India to start with, India's battery demand is expected to grow nearly tenfold. Today is about 25 to 30 gigawatt hour. I still remember the days when single-digit gigawatt hour numbers were seen as big, but we have already got into the mid two-digit numbers, racing towards the three-digit gigawatt hour numbers. And it's going to grow 10 times in about next 10 years. India's EV market is expected to grow from 2+ million last financial year, sold annually to close to about 15-20 million from an optimistic estimate. Even a realistic estimate is not going to pull that number down any significantly. What does it mean? EV battery market alone is likely to be anywhere in the range of $15 to $20 billion in about 10 years from now. That's the kind of number that we are talking about. And I'm not even counting the energy storage, which could be equal or a shade lower. But the fact is, more than 95% of the cells, I would rather put that number at 98% of the cells, are being imported today in India largely from China, highlighting the strategic imperative of why we should build a domestic value chain. India has announced more than 150 gigawatt hour of battery manufacturing ambitions. And ambitions is right now underlined because we are yet to see the first gigawatt hour to roll out of the factories while capacities are getting established. And less than 1/3 of this 150 gigawatt hour is the value addition that we will be doing in phase one, which means close to 65-70% of what goes into a cell will be created elsewhere outside India. And the other day I was reading that Niti Aayog said, by the time materials arrive into the gigafactory and you are building the cell, 50% of the value chain is already taken care of. That's the importance of upstream. More importantly, by 2030, and that's not too far away. I remember 2030 used to be a decade ago, but it's not even that. It's just 4 years away from now. By 2030, India could generate more than 150,000 tons of spent lithium-ion batteries annually. A couple of gentlemen on the dais are pretty keen on that number. I'm sure they know that. So a globally competitive battery ecosystem extends far beyond cell manufacturing. It begins with securing critical minerals and advanced materials, move through the cell manufacturing infrastructure, pack manufacturing, embraces next generation chemistries, safety standards, ultimately closes the loop through second life applications and recycling. Every link in this value chain must work in harmony. They cannot be looked at from a fragmented approach. If India is to reduce import dependence, strengthen supply chain, and emerge as a global battery powerhouse. These statements look very obvious, imperative, but there are a lot of challenges on how do we translate these statements into an actionable agenda that's financially viable, technologically possible, and supply chain wise de-risked. I think that's the key challenge here. The distinguished panel before us represents this entire ecosystem, and we have leaders driving innovation in battery packs, energy storage applications, experts shaping the future of advanced materials and specialty chemicals, pioneers creating circular economy solutions through mineral recovery and battery recycling. You can't ask for a better set of people to talk about what we are going to talk now. And over the next 45 minutes, we'll explore some very, very fundamental questions. How can India build a globally competitive gigafactories? How do we secure the raw material that will power our ambitions? Which emerging technology will define the next decade? And a host of others. I hope we'll have enough time to cover some of these significant questions, if not all of them. And I really look forward to it. Group them into 3 different rounds, and I'm starting with round 1, which is like building competitive scale industrialization from materials to manufacturing. As I fine-tune these questions, I would like to pass on the mic to my co-panelists here. Each one of you, in the order at which we are seated, if you can introduce yourselves, your organization, and what the organization is focused on, in a brief 2-minute introduction, that will help.
My name is Rahul Gogi, and I handle the growth and strategy for Evergreen Recycle Karo India Limited. We are one of India's R4 level recyclers recognized by Central Pollution Control Board. What we do is we procure e-waste and batteries and extract critical minerals out of it. So we handle the whole value chain of mineral extraction, and happy to be here.
Hi, good afternoon. My name is Venkat Rajaraman. I'm the founder CEO of Cygni Energy. We are into advanced battery energy storage system, both for electric mobility as well as for energy storage application. We have got a 4.8 gigawatt hour battery pack manufacturing facility incubated from IIT Madras, but focused on technologies, and we have powered over about 200,000 electric vehicles and then about 100 megawatt hour of energy storage products.
Hi, good afternoon everyone. This is Manish Rathi. I come from Minimines Clean Tech Solutions. We are an R4 recycler based out of Bangalore, southern part of India, with the capacity of expanding this year up to 15,000 metric tons per annum. We have indigenously developed this process of recovery of lithium, nickel, cobalt through an end-to-end, not just the process, but also machinery's part as well. So everything is built in India, for India, when we look at complete resilience for the country to build up, so that as we go for future, India can become more of a technology partner as well, where we can go outside and put more plans for recovery, especially in the South Asian and the African markets. Thank you.
My name is Robin. I represent Covestro. We are one of the world's largest polymer manufacturers. We come as a polymer bridge between the battery and polymer material science. So we enable the scale with respect to how quick you can scale up from megawatt to gigawatt, from how you deal with your plastic components. I'm a polymer engineer. So I've been working with Covestro for over 13 years and overall in the industry for 2 decades. It will be nice to discuss with you today about the mostly underrepresented polymer material science that we do when we talk about battery packaging. Also touching upon circularity and the safety aspect of it. I'm looking forward to have a engaging conversation. Thank you.
Thank you. Thank you for everyone to having kept it brief. I want to get started with the round 1, which is focused on building captive scale industrialization from materials to manufacturing. Let me start with Venkat. You've been in this for quite some time now. and have navigated through building the products and solutions to address the end markets. But in the last few years, India has announced several gigafactory investments, as we have talked about earlier. But cell manufacturing and pack integration are still evolving, as we see, because customers go and buy cells, what's available at competitive price elsewhere in the markets, but the packaging is required to be done in India. What do you think are the biggest bottlenecks in creating a globally competitive battery manufacturing in India? And when I say battery, it is addressing both cell and the pack. And there was a question in the morning in the panel one that was asked to me, and I have provided my perspective, but would like to know your perspective about, can Indian companies compete with Chinese players on cost, or should the focus initially be on reliability, localization, creating supply security, and application specific innovation that we need to do for Indian market?
Got it. Very loaded question, Vijayanand. So let me give you my perspective on this. So today, I think when we talk about gigafactories, right, I think we predominantly tend to think about cell gigafactories, right? But I think we should be focusing on the entire ecosystem. You know, it is just not the cells, but we need to be focusing on just not the packs, but also on the the power converters, the energy management systems, the software layer that needs to happen, and of course, the upstream, all the recycling which has to happen, along with all the innovations in cathodes and anodes and so on and so forth. So, which means that I think we may need to be looking at it as an ecosystem rather than just a cell gigafactory to begin with. Number two, the question was, can we compete with China on cost? My belief is that I think we should not be even looking at that from that perspective, because today you look at it, China has 2 decades of policy, subsidies, huge local market, very established supply chain ecosystem, and of course the domestic market growing at a rapid pace. So today, to talk about even that whether can we compete on cost, I don't think that would be the right metric. But I think, Vijay, you also answered. I think what we should be focusing on is on the other 3 things that you spoke about. I think clearly, the reliability and safety is going to be a very key factor. Today, all the, battery packs in the electric vehicles is, expected to run for 5, 8, 10 years. And those in the energy storage is going to come for, even longer, right? 10, 15, and 20 years. I think we will need to be designing now these packs with, extreme amount of reliability. Reliability builds trust, trust builds markets, right? So that is one. Number 2, I think we also need to be focused on, for example, application specific designs. I think, today, for many people in this room can vouch, the conditions that we work for, the Indian conditions is very different, right? In terms of, if I were to just focus on electric vehicles, the kind of temperature abuse that it undergoes, the kind of, Chennai is a great city, in monsoon, what happens in terms of flooding and so on and so forth. And in general, I think the vagaries of, in terms of all the climatic conditions. So I think designing, a product which is, specifically designed for a climatic condition for India could be our, USP as well, right? Because we knew that the products that are imported from, for example, Europe or US does not work here. Many of us have seen that. So I think that that is going to be a, key thing as well. Broadly, I think, in essence, I think maybe, instead of talking about a made in India batteries, I think we should be focusing on batteries which are made with materials which are made in India, right? So that could be a way to look at it. But I'll then take it up subsequently.
This question is to Rahul. At this point of time, homegrown technology is relatively non-existent when it comes to chemistry, cell and other things. A lot of efforts are going on. R&D level demos have been done. Some pilot efforts have been done, but there is no proven homegrown cell technology except 1 or 2 exclusives. So considering the specific requirements of Indian market, material security considerations that just now Venkat talked about, and the supply chain dynamics associated, What should be the key material innovation that India should prioritize in the next 5 years? I'm not talking about 20 years, at least the immediate focus. And as chemistries evolve from, as we see, NMC to LFP, then sodium ion, and how does the critical mineral strategy need to be adopted by India? And lastly, how can specialty companies or pharma manufacturing sector where India has proven competence at global scale, how do we ensure that capability and competitiveness is actually flowing into the battery chemical processing that we need to do?
So, as we know, what are the core metals or minerals go into a battery? It's lithium, cobalt, nickel, manganese, graphite. And you'll be surprised to know that India is almost 100% import dependent for securing all these critical minerals. So even if we have a full-fledged capacity that manufactures the very cell that makes a battery pack, we will still be dependent on these critical minerals coming from other countries. Now, it's not like we don't have the deposits of any of these minerals. We do have, but what we lack is the processing technology that is needed to convert cobalt ore into your lithium carbonate and cobalt sulfate and all these compounds that are needed to be purified to the level of battery grade, which can only be then used into cell manufacturing. So the very fundamental question is, we don't have the cell of a cell, like a human being has a cell. We don't have the very core component. Hence, the government of India has realized that there is no battery manufacturing ecosystem developing without the very fundamental security of critical minerals. There have been very encouraging steps taken by the government in the form of National Critical Mineral Mission, where developing new ores, investing in companies that can refine these to the battery grade are being done. And also the most important thing, India generates third highest amount of e-waste in the world today. We have a very thriving electronic vehicle market, charging grid is expanding. Consumer electronics sales are at all-time high. So we have batteries that are reaching end of life, and we ourselves at Recycle Karo are receiving tons and tons of batteries from major OEMs, which have been deployed in 2018, 17, and due to serious commercial use and wearing out, it has reached end of life. So these batteries can be an excellent feedstock for securing critical minerals that can form a basis for the cell manufacturing that has just been, just started as a budding industry. We, I think, have added 3 to 4 gigawatt hour of capacity for cell manufacturing in India so far. There's a long way to go. There's a 50 gigawatt or something approved capacity by the government. So what I believe is, for that matter, you might be wondering, what do we do with the extracted minerals? So there is no battery manufacturer or cell manufacturers, to be precise, who purchases from us. So even though we have the capability to create battery grade critical minerals, we are stopping at the industrial grade, and we are supplying to catalyst industries, paint and pigment industries, to pharma industry as well, right? So because we are 100% import dependent, we are at least able to cut the import dependency for other sister industries, right? What I believe is, India has to act on all fronts. First is recovery. Proper channelization of e-waste has to go, and recovery has to occur from there. Secondly, whatever stock we can procure from economically viable sources for all these mentioned critical minerals, we need to keep building up on that stockpile. And I think there's a need of a critical mineral bank which has all these critical minerals secured before the demand starts coming in for cell manufacturing. Because once we crack that code, our goal will only be to hyperscale. At that point of time, we cannot keep going out of the country, and just like how we are doing with the crude part, we cannot do that for batteries. So I think that should answer.
So what I hear is the strategic reserves that they have in crude, we should create something like that for critical minerals going forward.
Absolutely.
This question is for Robin. Robin, in your opening remarks, you said some of the specialty polymer chemicals are the most underrepresented but have a very critical role to play in the final solution delivered to the customer. So question is, advanced materials determine battery performance, safety, not just at the cell level, which gets all the attention, but the pack level as well. So beyond active materials that go into the cell, how critical are structural and insulation materials in determining the pack safety, weight, manufacturability at gigafactory scale, and whether that's a low-hanging fruit for India to localize it faster than the critical mineral value chain?
Thank you. Thank you for the question. So I'll just connect it with the first question which you had, which Venkat has answered. So how close are we to replicate the success of China? So I'm so my organization and my team has been part of. We are the enablers of how China is today in the scale they are now. So we have worked on these lines about the polymer materials which are needed to achieve the safety, scale, and lightweightedness that is needed. Again, this is very specific to each individual application. Yeah, it is not one solution for all packs. Yeah. Safety point of view, most of the India now has learned about need for fire retardancy. Yeah, and we also have local regulations in place that certain level of safety is needed. Yeah. Then what we have seen as an organization and working closely with the OEMs in India is the missing link is that we are thinking of polymers as during the design as an afterthought. So once you have a demo ready and some level of design ready, then we talk about what material to be used, how to manufacture it. So that comes as a hurdle because you may have to skip that what we call a generation of pack. You may have to go to the next generation so that we can include that into the overall picture. One key especially in the large scale volumes that we see in two-wheelers. Yeah. So one key parameter we see is that you have assemblies done on the designed pack, and you are making SOP started. Vehicles are on the road, but the moment you put those overall process into robotic arms, you need millimeter level precision for your parts which go into it. It just doesn't fit because otherwise if it's a manual manufacturing, you can just squeeze it in and do the welding and do the screwing. But when you talk about polymer holders for your bus bars, for your cells, so dimension stability or fire retardancy and weight, these are all coming into picture. So when we talk about scaling, scale for this level of, let's say, gigawatt level of the battery packaging in India, we will have to make sure that when we talk about automation and our overall design, pack design, material considered for your packs are all enabling this. So I think that is a low-hanging fruit because it's just a thing is that, because we have solutions from around the world, we have lessons learned from around the world, and we have use case based, the engineered polymers available in India. So only thing is that we have to consider these well in advance of your design stage. So I think it's possible with the right outlook into the designing process.
So, I mean, from my own experience, we have seen that the prioritization of localization could be based on a Pareto of which is the highest value item to the lowest value item. Flip it around and say which is the easiest to localize to toughest to localize. You will start actually adding up a lot in your BOM into that.
True.
Yeah, thank you. This question is to Manish. Manish, you have worked in the cell technology development earlier and right now promoting recycling. Where do you see the right balance between indigenous technology development and the technology, accessing technology through partnerships? And Are we at risk of investing in technologies based on what's happening now that may eventually become obsolete before we actually reach the scale that we want to reach? Do you see that as a risk in what's happening in the market today?
Thank you so much for the question. And yeah, that's as we are speaking about the integrated ecosystem that we are trying to build in India. So, having worked on both sides of the market, like cells as well as batteries and now recycling. So, to me, my personal view, having worked on the ground, looks it as in a way that we should be promoting both together hand in hand so that India could integrate an ecosystem in a well-defined manner and we achieve the success metrics to achieve the 10x size of the market that we are building today for the electric vehicles and definitely move towards a tera watt hour market. So technology transfers definitely helps to target three particular aspects. Number one is competency that we do not have. We do not have manufacturing competency. We do not have R&D competency. So first is that when we have technology, we understand what are the critical to quality parameters, what are the business parameters, supply chain parameters, overall in a way that a product success is not just from its performance point of view, but also from the cost and quality and the delivery that are required in the market. Especially these are the three parameters that an automotive market looks at. If these three parameters don't satisfy, none of the Indian OEMs under IATF would create you as a supplier. So when you have a proven technology, that is what is going to help in scaling and entering the market, and definitely for someone to be first to take the market. Parallelly, we could what again Amar Raja, Excite, and Reliance, all the cell OEMs who are working in this field already to create a gigafactory have already pivoted in this regards to have a technology partner who has already commercially built a cell outside, have done gigawatt hour of sales, which is a proven technology in the vehicles which have gone out in the market, and then successfully looking at in the same manufacturing setup, can we make a more indigenous setup, more indigenous supply chain? So R&D does not mean that when we look at that, we have to develop a new chemistry altogether. Can we dope the cathode itself? Can we make something more of an alternate cathode where we can have a cost reduction, where we can spike the performance? It doesn't have to be a complete new process or a new R&D. Can we pivot in a way where we have our own product and our own supply chain? So that's where a 3-year roadmap can convert to a 5 to 7-year roadmap, and then a longevity towards a 10-year roadmap that we then we can become an export-oriented country as well and rely less on China. So yeah.
So I think the answer is that it's not either or. It's got to be
has to be
that you
and.
don't try to reinvent the wheel that's been already done elsewhere. Adopt it at the speed at which you need to, but then customize and build it for India as we go along in terms of technology capability.
Yes.
Venkat, I want to move on to the other topic. In my conversations with many customers, what I realize is that both the technology teams and the commercial teams at the customer end have the option of buying cells today from a supermarket called China, which means they get all the variety of SKUs, variants and everything else. And almost every quarter there are new announcements being made. So when we try to agree on what should be built in India, the goalposts keep changing. So, then the dilemma comes, what's the kind of product portfolio that we should be investing behind? So question is, how important is standardization of cell formats for Indian market and pack architectures to accelerate EV and the stationary storage adoption from a very fragmented approach perhaps taken right now? If you see Europe, they have taken a very standard brick model, that you build around that. Should there be national standards for cell form factors, or they should be left to the industry to evolve? Because when standards mandate, people say that innovation gets killed. So where do you resolve this dilemma?
Yeah, so my answer may not resonate with some of the folks, but let me sort of put my perspective, and then it will be a great question for discussion subsequently. See, today, for example, if you were to look at the cell in terms of form factors, right, whether it is cylindrical, prismatic, or pouch, they all exist for a certain reason, right? Each one of the form factor addresses a certain market. For example, if you want to have a large scale energy storage, it would be very difficult to do with a smaller cylindrical cells, right? So even within the cylindrical cell, if it is 18650 or 21700 or 4680 or 46120, each one of them catering to a certain application in a way. So if you were to ask me, Vijay, I think standardization at the form factor level would be stifling. Okay, I'll pause it here. I'll tell you why I'm saying what I'm saying. But I guess the standardization would be required at the system level, right? For example, today, especially for, we talked about the swapping application in the morning today. Similarly, for energy storage, for example, if you want to replace one cabinet with somebody else's other cabinet, it does not work because the interoperability between the energy storage, the battery pack to the the inverters or to the power conversion devices, or the interface to the energy management system, or the interface to the power plant controllers. Today they are not well defined. Okay, so I would rather standardize at the system and interface level, which can actually enable interoperability and compatibility, but not at the cell form factor level, right? Having said that, okay, I also believe that there is a large amount of digitalization that we can do at the cell level. I think anyway, we are going to be talking about, for example, the battery passport or a battery Aadhaar, as we could call it. I think some of that would also help us in terms of how do you sort of innovate even with the different form factors which are there. But in essence, I agree with you. We tried the standardization for the battery swapping industry. We did not succeed, right? Because really it is about how much of standardization can you do. If you want to standardize on the contours of that, I think it is acceptable. But if you want to be very rigid in terms of the dimensions, in terms of the rest of the features, then the industry may stifle the innovation. So it's going to be a trade-off between the two. But for me, I would rather not standardize on the form factors, but I would rather standardize at the system level for interoperability, Vijay.
Thank you, Venkat. The other thing that comes to my mind is that India currently on the EV side is largely two-wheeler market, and two-wheeler operates at low voltage architecture. But as you see what's happening elsewhere in the world, particularly in China, on the passenger vehicle market, they moved from 400 volts to 800 volts and challenging the charging times to less than 15 minutes, which you can't achieve with low voltage architecture. So, and again, India cannot wait for, these upgrades to be done as we are catching up with the fundamentals. So my question to you, Robin, is, as EV platforms migrate to higher voltage architecture, what are the implications for battery pack design around the cell, beyond the cell, and specifically insulation performance, creepage distances, structural integrity? Is India's material supply chain and pack design and manufacturing capability ready for this?
Yeah, thank you. Very valid question. Especially we are at the junction where especially four-wheeler passenger vehicles are moving towards the 800, 600 volt architecture. Yeah. So here, what we see was that there was a lot of development that we have done on a pack level to ensure the scalability by choosing the right material. Yeah, after multiple iterations in the generations of the battery pack by each OEM. But when it comes to the higher voltage systems, 600 volt, even 400 volt, the material required, like Vijayanand mentioned about the creepage resistance, how close the terminals can be kept, how high voltage can be given to towards an insulator. So there we actually went back to where we were in the generation 1, because we were trying to achieve it through heavily glass filled material which are not dimensionally stable and heavy in weight. Yeah. So again, the question is, how do we find out application specific designs? Yeah. So again, we are coming back to the design aspect of it. There are solutions because we have this 800 volt already streamlined in many of the battery developed, the developed markets where lithium ion battery packs are being used. Um, so there are solutions which are available on a pack level where you can achieve these higher voltages, not only in battery pack, because when it comes to battery pack, you also have to consider the charging infrastructure. Yeah, because high voltage, we are talking about 1000 to 2000 volt of electricity coming onto the battery pack. Yeah, so there are polymer materials which can achieve that in the the high voltage scenario with a very low electrical creepage. And we have cases where some of our customers in India were trying to do a bus bar holder which is 2 meters long. And how do you make sure that this is dimensionally stable for the robot to place it in a sub-millimeter accuracy? So there are polymer materials which can achieve sub-millimeter flatness for a 2 meter long part with the right inserts and bus bars and all handled. Then this also comes to the going back to the basics about resistance in the overall system. Yeah. So if you have used in a low voltage battery aluminum as a resistor, I mean as a conductor, the resistance is slightly higher. But when you move to higher, the current and ecosystem overall, you're going making your battery pack bigger. You have to look at the conductivity of your conductors. Like you cannot use, let's say, aluminum for a high capacity material and then try to mitigate whatever the heat generation that is happening on a pack level by trying to address this as an afterthought. Again, we are talking about the basics, coming back to starting from the design stage itself, that you consider the right polymer materials or overall system as an on its own, rather than looking at each symptoms as an afterthought. Yeah.
So I think, Robin, you brought in some good points, because generally we tend to believe that if cells are available, we can build the packs and it's all about engineering. But I do agree with you that if a OEM need to rely on an Indian pack manufacturer for 800 volt system, it's not an easy job to get qualified for that. So many of these intricate dimensions are involved in that. Thank you.
Correct.
I want to spend the next couple of questions more on recycling, considering the time. I would like to reach out to Rahul and ask this question. You mentioned about critical minerals being recovered from black mass through certain recycling technologies, and you still don't sell to any Indian cell maker, but you have the capability. I want a little bit more focus on this aspect, because I know something like this is not as much talked about. So which critical minerals Indian recyclers are already recovering, and what viable pathways exist to ensure a consistent and reliable domestic supply of these materials from recycled batteries? And critically, whether the recovered material can meet the purity thresholds, because the qualification of material is a very rigorous process, not just at the cell maker level, the OEMs also get involved to validate and other things. So whether they will meet the purity thresholds required for particularly cathode grade manufacturing and battery grade applications.
So if I have to focus on what runs recycling industry, it pure play comes down to the economics of it. There are various lithium-ion battery chemistries that are deployed in the market. Previously, there was lead acid, right? Now we are moving towards solid-state batteries. Sodium-ion is into conversations. So the Indian recyclers who have built their capability in the last 10 years, they have focused on what all feedstock is available. That's the number one preference. Secondly, is the feedstock going to make sense once you recover critical minerals out of it? To give you an example, LFP is a battery chemistry that recently has started, getting the amount of traction due to the cost factor and the resilience that the chemistry shows in Indian usage and weather conditions. Previously, LFP was not that prominent. So Indian recyclers have been recycling NMCs, that is the favorite chemistry of Indian battery recyclers. NMC is there. And as I said, LFP has just come in. LCOO is one chemistry, lithium cobalt oxide, which is primarily found in high quality consumer electronics that is being actively recycled. Now, the content that comes out after recycling decides whether a recycler would prefer recycling it or not. Okay. If I speak about Evergreen Recycle Karo, we have a battery recycling capacity of around 10,000 metric tons per annum, and we procure batteries, end of life batteries, from 90% comes from the OEMs, and we have a consumer facing vertical as well. From there, around 5 to 10% comes in. So we operate at a efficiency which is upwards of 95%. Let's say, to give you a simpler understanding, let's say a battery worth 100 kgs has around 20 kg lithium. Just to give you an example, we are able to recover upwards of around 18 to 19 kgs to get the economics right. And the same thing is applicable for all other chemistries. Now, once we recover these critical minerals, we sell it at the market prices determined by, let's say, London Metal Exchange, Shanghai metal markets, right? And the Indian prices do vary a little bit, but the amount of money a recycler makes is directly proportional to the what is the value of the critical minerals that they extract. Now, as Vijayanand mentioned, I spoke about capability of recycling metal, these critical minerals, to battery grade, primarily cathode grade. When I am speaking about that, we are somewhere speaking in the range of 99.98 and upwards. It could be even higher. It depends on the use case and the preference of the manufacturer. But going from 97, 98 to 99.98 and in that range, the amount of additional processing that you need to do significantly increases. So does the manpower, the electricity costs, and the time spent. There are all of these factors that influence what are you going to get out of after reaching there. I believe at least all the top serious recyclers who are certified by CPCB, including my colleague from Mini Mines, we do have the capability to recycle at that level, but economics is what holds our hands at the moment. The process that I am talking about is primarily hydrometallurgy. It is not a rocket science in a way. If you look at the technology, it is widely used in the recovery and recycling of all other major metals as well. But what differs when it comes to e-waste and battery recycling is fine tuning of that process to the very level of the product that you are recycling. Let's say in the last 10 years, we have collected a data of around 16,000 different electronics and battery configurations. So we exactly understand by looking at a particular battery and knowing the type, we exactly know what is the roughly derived component percentage of various critical minerals. This data is very crucial because if we don't have this, we will not be able to give the right price to the seller. And if we are overcoating, we will be at loss and we might go out of business. But if we are undercoating, there is competition that's going to come and cut us out. So it's a hydrometallurgy process which is fine-tuned based on the feedstock. And this fine-tuning is what decides whether a recycler is going to get it right, are they going to sustain, or scale to the level where they can operate at commercial scales. So yeah.
Yep. I think science, technology, engineering, innovation, they are chased by economics everywhere. You can't probably
Especially in
dealing
India,
them at some point of
economics is
I want to take a step back, Manish, and look at our broader picture of recycling in India. What, in your view, is the single biggest challenge in India for establishing a true circular economy framework for batteries? And is it technology? We talked about economics. Is that the one that's limiting us? Is it regulatory framework or the mixed market of organized and unorganized reverse logistics that we always deal with? Where do you see the problem is?
So, when we look at what is the challenge that we have today, or at least for 3 years to come, that the Indian recycling ecosystem would face, uh, uh, if we do a shareholding or if we reverse the pyramid, the largest share would be of feedstock. So anyone, and that links with all the angles, that links with economics as well. So today, let's say whatever market size of India is, you quoted 30 gigawatt hour. If we compare it with China, China's recycling market itself signifies 3 digits. So, what we are deploying batteries in market. China is already 3 to 4 times of that market in recycling ecosystem. So how things are working for them is they have volumes. You have volumes, you scale, you make, you produce, you sell. You have a basically complete cash flow system. You're working cash. So basically, you're running an enterprise in a manner that the business has reached a stability, and you are good to go from there. So that solves the revenue. From other point of view, Indian regulatory framework and the recent critical mineral push that has come under the union budget in last financial year, so that has been very supportive in a way. How as the feedstock would keep on increasing, how various PLIs came to support the capital investments to recyclers who are trying to establish a hydrometallurgy unit would benefit, or at least offset some of the cost that they are incurring on a recurring basis. And the other aspect that again links to feedstock is the variability in the upstream. So when would the batteries come? So typically the market kicked off in 2022 when an upside came. Adoption started, two-wheelers started seeing, and three-wheelers market, now electric bus market came, now electric cars are seeing the uptake. So a mix of uptake followed by the chemistry adoption, where we have NMCs primarily driving the two-wheeler market, LFP driving rest of the market, including energy storage. And now the batteries which OEMs, battery manufacturers are designing, so they have a longevity of at least 8-10 years if they are used well, if they have been put down well, and they are serviceable as well. And then once these batteries come back from the market, so that's what they see the first life. Typically, the health of these batteries are still 85%, 90%. Today, an Indian, like most of us, are giving away the vehicles or batteries. Especially, most of us would have driven Nexon, or a friend drives Nexon. They are given because it has fallen a range below 300 kilometers. Battery is still intact, but you don't want to daily sit and charge and have anxiety that, oh, I have to charge. And largely the fleet owner. So that's why the batteries are, so that's where a second life comes into an account, where basically an home application or somewhere where we can power or support certain CSR initiatives are taken. So finally, so this again links with the feedstock. So feedstock, and now where will we get feedstock? So to answer this, largely in recycling ecosystem, two-thirds of the feedstock is driven by cell manufacturing. So if a cell manufacturing goes live, that creates a gigafactory based cell manufacturing scrap that is being given to the recyclers. They extract metal salts, metals out of it. Then they give it to the cathode manufacturers, and then finally is when they come across to the sustainability. So, in nutshell, feedstock remains as an answer, and in 3 years, by 2030, we'll see that a lot of cell manufacturing companies would be live.
Yep.
So, we'll be generating feedstock for the recyclers in larger scales.
A lot of ideas there to further explore. We're running out of time, and I want to leave uh, an option for the audience to ask 2 questions. I'm sure the panelists will be available after this session for following up the dialogue, but the gentleman there.
Sa-
Hi, sir. This is Vinod here from Bangalore. So I have a one question, which is been asked from a lot of customers, where they usually when they go for buying EV vehicles, they usually give a warranty for the battery of 5 years, and if you want to have an extended warranty, they might give you another 2 years. So the customers are worried about after 5 years the vehicle will be in batteries are not able to use. So you in this forum we were talking about the recycling of batteries. So those how does it really helpful for the customers when it comes to deterioration of the batteries after 5 years? And that is one question. Another question is when we compare with the normal ICE vehicles and EV vehicles, the resale value is more potent in ICE, yeah. So how do we define and make the valuations of a vehicle in terms of EV? How it can come and compete the EV market?
Do you want that to be answered by any specific panelists, or you just? that's it?
I want you to answer, sir, because you are.
Well, I think it's a little out of syllabus question, considering that we are talking about Gigafactory, but I'll take that. 3 years ago, when I was contemplating buying an EV, being part of the industry, there were 5 different reasons why people don't go for EV that I was aware, but I have an answer for each one of them. The 6th reason that people don't go for buying an EV is because exactly this question: what is the second, sand value of the thing? Insurers have a problem to arrive at that. The financing, institutions have a problem to arrive at second sale value of the vehicle. And I think as the ecosystem matures, as there is more predictability of battery life, today somebody is saying 8 years life, I am giving warranty. There is no data to say that batteries do last 8 years from field condition. It's a simulation done based on life cycle tests, accelerated deterioration tests and all of that, and data drawn from other countries. Obviously, we'll have to modify the data based on our usages, our traffic conditions, our environmental conditions, and the way the overall vehicle is designed. But OEMs are taking a bet on that and then providing warranty coverage. And in the modern era, typically the vehicle life is about 12 years, 10 to 12 years, sometimes extendable to 15 years, more as a memory. I don't think vehicles, older than 10, 12 years is something that you want to own unless you have emotions attached to that. The first-hand ownership, as per market data, is about 4.5 years. People want to change their vehicle after 4.5 years. So the issue of second sale becomes important, and the warranty, if it is not applicable for the second buyer and is limited to only the first buyer, again, that's where the thing. So this is, the question that you raised hasn't been fully resolved, but as the industry matures, some of these financial guarantees second sale value will come in as a way of the market competitiveness, not because there is a very good technical solution available. And matured markets like US, the battery lasts as long as the vehicle lasts is what people talk about. It's more like lifetime warranty for that. I know that's a little long answer, but it doesn't really address the question that you have raised. One more question, if there is any more questions from the audience.
Do you have any more questions?
Okay, just to conclude, I want to.
We have one question there. We'll just take that as the last question.
Good afternoon, everyone. I'm Ravindran from Indo-US company called Bridge Green Upcycle. I'm heading as a VP technology. Question here to your team, particularly a couple of people are from the recycling segment. One is from Recycle Karo, and other gentleman is Manish coming from Mini Mines. Question is, there is an Indo-Europe connect which is happening. That's for the fund is about 16.9 million, close to where they are expecting. That's the Ministry of Heavy Metals is conducting this discussions. And what is the take on it? Is it going to be, because it is a 36 months duration, they're going to complete the proto from say TRL level 3 or 4 to be taken to TRL level 8. And what is your take on that, whether it is going to be useful for India or how is it going to be benefiting, because it's you are anybody of you are participating in that, or what is your thought process for the Indo-Europe program?
So, Rahul, I want you to take that question, but to keep the answer limited to 1 minute. Maybe you can have an offline conversation later.
So, particularly this Indo-US initiative is probably going to benefit recyclers who are wanting to scale from the lower TRL levels to higher TRL levels, who are at black mass extraction stage and are wanting to get into sustainable and efficient recycling of critical minerals. I think it would be good to look at it as a incubation plus nurturing system. If you ask me, is it going to have a significant impact on the national recycling ecosystem that we already have? I don't think so, because everyone is actively working with some or the other technology, working in collaboration, discussions. We as a community keep engaging always. But I think it's a good thing to get exposure of what's happening in Europe, and this is a formalized, funded, and structured way. So it's a good opportunity
We
for
have
new
completely
people.
run out of time for answering that question, but you can have an offline conversation on that. Before I conclude, just want to take one common question to all the panelists, probably a 30-second response. If we were to reconvene here in 2035, assuming Sanjeev will call us back that year again, what would success look like for you in India's battery ecosystem from gigafactories to the grid? Let's start from Rahul.
So
Very brief answer.
If we meet in 2035, success for me would be able to recover each and every gram of critical minerals out there in the ecosystem and route it back into the circular economy, so that our cell manufacturers, who will definitely be active by then, can thrive and compete globally.
I think I can copy paste that answer to Manish also, probably. Coming from the recycling, but you will get a chance to answer.
Yeah, so for me, 2035, success would be where the entire ecosystem is built, right? We talked about, for example, owning the mines. We talked about processing of these materials. We talked about, urban mining. We talked about, the rest of the upstream ones. So if we can build this end to end, okay, it's just not some gigafactory or not some technology, but we build it end to end and also keep it in a way, agnostic. I wouldn't even know in 2035 we'll be talking about LFP, so I would be very much hopeful that we talk about maybe a solid state battery, maybe a sodium ion. I think we need to be, as a country, be, open to alternative chemistries which can give us that energy independence and build the end-to-end ecosystem.
So for me, it will be like vertical integration beyond India. So that's what I look at it from end-to-end perspective.
Thank you.
For me, the dream scenario would be that as important the cell chemistry is considered during consideration of a new battery pack. So similarly, a polymer material is also considered in the beginning stage of the battery pack design. At the same time, the recyclability is also considered, because now I understand that when we talk about recyclability of battery pack, it's only about these chemicals in the cell. But the main reason is the dismantleability or the recyclability, and at the same time, the second use, how we can accommodate the second use of these packs as a system. So hopefully the polymers are also considered similar to the level of battery chemicals in the coming years. Yeah.
Thank you. And my answer to that would be 10,000 highly capable PhD scientists seriously involved in developing battery technology.